For multiple reasons, it's important to be able to recognize perfect square trinomials. These are trinomials that will turn into something plus something squared. This will serve you well in this unit in addition to discovering the quadratic formula, solving quadratic equations, using a technique called completing the square. So it's a good foundation to build upon. So if you're looking at x squared plus 16x plus 64, you might think, well, I want to factor that into two binomials. I know I want an 8, and hey, look, when I get 64 and when I add my O and my I get 16x. Cool. Thanks so much, honey. So I get x plus 8 squared. Looking at x squared minus 12x plus 36, that's going to factor in 2x minus 6 squared. For the next one, I'll have xy plus 5 squared. These are perfect squares. They factor into something that you then square. So let's start getting the hang of it. This will be x plus 17. I know that 17 plus 17 gives me 34x. Cool, squared. X to the 5th, y to the 10th, y to the 5th. How am I getting these terms so quickly? I take the square root of this and the square root of this. The square root of this, the square root of this. And hopefully you'll notice the relationship between those and your middle term. This next one doesn't look quite as familiar because I have a coefficient up here, but you know what? This is still a perfect square. This is still a perfect square, just like all of the ones that have come before. I'm noticing a pattern when I take the square root of this and the square root of this. Those are my numbers that I get as my first and second term of the binomial. And when I multiply those together and double them, I'll get my middle term. So is that actually happening here? So if this is 2x with a 7, when I multiply 2x and 7 together, I get a 14x. And when I double that, well, yeah, I get 28x. In this case, I need it to be a negative because we have a negative right here. Well, this is just a repeat of this one, so we don't need to do that one. Whoa, this is weird. Okay, well, if I follow the rule, I take the square root of the first term. I take the square root of the third term. They're all positive, so I'm going to add. Somehow I kind of don't believe that I'd get a middle term of 2x, so let me check. So a third x times 3, that'll just give me an x, and 3 times a third x, that'll give me another x. Sweet, I get 2x. Cool, so this simplifies to 1/3 x plus 3 squared. This is indeed a perfect square trinomial. All right, so following the rule, square root. Is it true that when I multiply those together, I'll get 6v, and when I double it, yeah, I get 12v. Cool. It has to be subtraction because this is subtraction. And when in doubt, you can always FOIL it out to check. So question, are these perfect square trinomials? If they aren't, fix them. So we've started to develop a rule. If we take the square root of the first and the square root of the third, and we multiply those together, and then we double them, we should get the middle term. Yeah, this is not right. So what do I need? I need to make that squared. This will now factor into x squared minus 4y squared. Is this a perfect square trinomial? Well, 1/3 x and a 3 When I multiply those together, I get x, but I need to double it, so I need a 2x right here. And now this will work. So if I take the square root of this and the square root of this, okay, I'll get 70xy. Cool. Oh, wait, no, I forgot. I have to double it, so never mind. This has to be a 140xy. All right, the next one, 5m and a 2. When I multiply those together, I get a 10m, but then I have to double it, so I need a 20m. Now this would work. You might be asking, why do we have to double it? Well, FOIL has an O and an I. So you're doing the same thing twice. O, I, 1 and 1, 2. So the F is 25m squared. Cool. The L is 2 times 2. But the O is 5m times 2, and the I is 5m times 2. So you have a 10m and another 10m. So the fact that you have a squared plus something and a b squared, and you have to multiply those together and then multiply by 2, well, that actually makes sense because the O and the I, you have 2 of them. And you know why else this makes sense? Is because if you if you FOILed out a plus b times a plus b, you get a squared plus 2ab plus b squared. So if you ever forget the coordination between the 3 terms of a perfect square trinomial, just write out any example of a perfect square trinomial and experiment. So I'm going to ask you to fill in some blanks sometimes. Okay, so we just talked about looking at this as an example. The middle term always has to be 2 times the a and the b. Now, how do I get, this is really the equivalent of a squared, so how do I get the a? Well, I'll just take the square root of it. So this is going to be 2 times 10x times the square root of this, times a half. So I'll get times 1/2. So I'll get 10x. Let me check that. So 10x plus 1/2 times 10x plus 1/2, 100x squared, O, 5x, I, 5x. Cool, that gives me 10x. The L, 1/2 times 1/2 is 0.25. Cool. All right, so now I'm looking at the fact that I need 2 times 3x squared times 1. Okay, this just needs to be 6x squared. And then I'll get 3x squared plus 1 squared. For this one, I need 2 times a 2x times a 7. So 28x. So this should factor into 2x plus 7 squared. If I'm not sure, ever so easy to check it out, FOIL it out. 4x squared. Cool. 14x plus a 14x. Cool. 28x. 7 times a 7. Sweet.